Okay, let's try this problem. What does it say? To calculate the equilibrium constant of the reaction that is represented by this general chemical equation. If you know that, blah blah. Well, you see concentration, you want equilibrium constant, what are you going to do? You will have to do what? A nice table. Do you agree with that? So you write these things kind of far away from each other, so you have space to work with. You learn to write correctly. Otherwise, it becomes a mess, and then you don't get the answer. And you know how to solve it, but you missed it because you did not write. You were writing sloppy, and becomes sloppy when from the beginning you don't plan. You have to plan when you write. Otherwise, it will get cluttered, and then the mistake happens, and then it's multiple choice. You lose the whole thing. There's no credit. So we're going to see the ice table, right? Do you agree with that? So here is the initials. So initial, what do we have initially? We have 8 moles. You should put what? Sometimes makes a big difference. Okay, it's concentration number of moles. Okay, you have to be sure that you do that. It talks about not concentration but number of moles. So you put the word mole, 8 moles. And then we have for B, we don't have anything, 0 moles. And for C, we have what? 5.3 moles. Okay. That's initially. We want equilibrium concentration, right? Right here. So now, we say when the system goes towards equilibrium, it's going to move right or left. Which way will go? Right. Whenever you have 0, it's going to be produced something. So how is it going to be produced? B. Going this way? There's no B, so C2 reactor will go that way. So whenever you see 0, it's going to be replenished. So it's going to go that way. Or you can see this way. Q is what? This times I divided by this square. The Q is 0. Isn't it? And that means it's less than equilibrium constant. Equilibrium constant cannot be 0. It will be always positive. So Q is less than the equilibrium constant. And it's going to such to become equal. So Q has to increase. How Q is going to increase? When the numerator is increasing, denominator is decreasing. Which way will happen? If it goes from left to right, right? But you don't have to go that way. Just see. Where is 0? Okay, that way it will go. Okay, so it's going to go from left to right. How much? Y. Don't put X, because when you put X, sometimes you are confused with the sign of multiplication. So it's better to put Y instead of X. Y. Now, there is a rule. When you put a known Y, you try to put on the component that has a coefficient 1. So I'm not going to say YA reacted, so minus Y, and minus Y half, minus Y half. It's complicated. It will make a mistake most of the time. So it's a good rule of thumb. The answer will be the same. To call Y any of the components that has coefficient equal to 1. So coefficient equal to 1. So we say how many B's produce moles when you reach equilibrium state? Y. So it's plus Y. 1 to 1. So I have plus YC. 1 comes from 2. So Y will come from where? From 2Y. And here has to be minus. Right? See? So now I don't have Y and a half, or Y divided by 3. It's getting complicated equations that way. All right. You still have the same problem. Okay, so equilibrium is going to be what? 8 minus 2y. And this is going to be y. I have just put it like this to make it nice. Do you agree with that? Kind of make a mistake. It's harder to make a mistake like that. Okay. This should be, right? Now, What does it tell us? What does it tell us? It tells us that the equilibrium concentration of B is 1.5 moles. Isn't it right? Or no concentration, sorry. The number of moles of B is 1.5. So really it's giving us this. This, we know it's how much? 1.5. Do you agree with that? It tells us that. So Y actually is 1.5. We know that. If we know that, then the equilibrium concentration is going to be 8 minus 2 times 1.5, 1.5, and this is going to be 1.5 plus 5.3. So really the equilibrium concentrations are how much? How much is this? 5, right? 5, 1.5, and 6.8. These are moles, remember, moles. All right, we are ready. So what do we want? The equilibrium constant. What's the equilibrium constant? We have the equilibrium, what? Moles, no concentration. So be careful, right? So Kc, that's the equilibrium constant, right? You see, you can have equilibrium constant, K equilibrium in general, right? Then you have Kp as a function of pressure. Then you have Kc as a function of concentration. The concentration would be usually molarity, right? You can have Kn as a function of number of moles. You could do that too, but it's very seldom. But look at this. In fact, in this case, Kc and Kn are equal. Why? Because delta Ng is equal to 0. Whenever delta Ng is equal to 0, Kc is equal to Kn. In some concentrations, number of moles. You will see that now in a minute. So the definition of equilibrium constant, by definition, is concentration of what? C times concentration of B. These are equilibrium concentrations, right? Divided by concentration of A and equilibrium to square. Do you do that? Okay, now, the concentrations are number of moles. There are number of moles, so it's the number of moles of B divided by the volume B, which we do not know, times, I just put it the other way around, doesn't matter. Number of moles of C divided by V, and then you have number of moles of A divided by volume square, like this. So look, V and this square goes away. So really, you have instead concentrations, you have number of moles, NB times NC divided by NA squared. And if you put the values from here, right, these values go here, then you will have 0.41. Now, if you have experience, you know that when delta Ng is equal to 0, for this reaction, delta Ng is equal to 0. Can you see that? Because it's 1 plus 1 minus 2 makes 0. Only the gases, not solid or liquid, only the gases. So delta Ng is equal to 0. Whenever you see this condition, then Kc with molarities is equal to Kn with number of moles, because the volumes go away. If it was not 2 moles, delta N is equal to 0, but delta Ng was different than 0, then you better have the volume, otherwise you cannot calculate equilibrium constant. If the problem is giving you moles in concentration. You got it?